All right, y'all. So Jason, points have been added for test one so far, but not test two. All right, y'all. So 8.3 polynomial division. And really, the only division we're going to do in this section is what we call synthetic division. Now, there's two things we're going to use synthetic division for. In this section, we're going to use synthetic division to find function values. And we got a little theorem that says the remainder from doing synthetic division is equal to the function value of that number being evaluated for the polynomial. So what this means, if I had a polynomial and they wanted me to find f of 5, in the past, we had to put the 5 in for all the x's, and then we did order of operations, and we came up with a function value. Well, now, if I got a polynomial, I can use this synthetic division, putting that number into the C for synthetic division, and the remainder that I get would be equal to the function value. And then I'll show you how we're going to do that in a second. Now, the second thing we're going to use synthetic division for in this section is to determine if a number is a zero of a polynomial. Okay. Now, what tells me if a number is a zero of a polynomial? And remember, zeros are solutions you get when you actually set the polynomial equal to zero. So when we use synthetic division, if a number is a zero, we got what we call the remainder theorem. And this remainder theorem says that if a number is a zero of a polynomial, then the remainder from synthetic division must be zero. So if a number is a zero of a polynomial, when I do my synthetic division, I better get a zero remainder on it, okay? So y'all, what I'm going to show y'all next is actually how to do synthetic division. And I'm going to do it on a problem and we'll write out the steps as I'm doing it, okay? So we're going to start out using synthetic division to find function values. So using synthetic division, find the function values. Okay, so they're giving us on this one, they're giving us f of x equals x cubed minus 12x squared plus 47x minus 60. Now they want me to find, now we'll do this 3 times on this example. So they want me to find 3 function values. They want me to find f of 3. Then they want me to find f of negative 4. Then they want me to find f of 5. So when I do this first one, I'm sort of going to write the steps as I'm going through the problem, okay? All right. So the steps. The first step we're going to do, we're going to look at this polynomial and we're going to write out all the coefficients. Now remember, the coefficients are the numbers. So the first coefficient would be a 1, a negative 12, a 47, and a negative 60. Now, if any of my terms are missing, you see how they're in descending order? If any of the exponent spots are missing, we would have to put a 0 in for it, okay? Now, this one, I'm not missing anything, so I don't have to add any zeros. So my first step, write the coefficients of the polynomial. All right, y'all, so my coefficients are 1, negative 12, 47, and negative 60. Next, I'm going to set this up. So next, I'm going to leave a little space in here, and I'm going to draw a line, and I'm going to box under the last column. This little box right here is going to be the remainder when we're done, okay? But leave a little space in here because we'll be writing numbers here, okay? Now over here is the number we're evaluating. We call this our C. C is the number we're evaluating here. So if I want to find f of 3, then C would be 3, okay? So write C to the left. Right. So now this is just a repetitious cycle we're about to do. The first step, we automatically bring our first number down. So bring the first number down below the line. Now, when the number's below the line, I'm going to multiply by C and put that in the next column. So multiply that number times 3. So multiply the number below the line times C and put into the next column. All right, y'all. So 1 times 3 is 3. So we're going to put that into the next column. Now, when you got 2 numbers in a row like this above the line, these 2 numbers we're going to add together and put the answer below the line. So add the column and put the answer below the line. So y'all, here we go. Negative 12 plus 3 is a negative 9. All right, so y'all are asking me, where did I get the 3? Okay, so remember, right here, I brought my first number down below the line. Now, multiply the number below the line times C. So I took this 1, multiplied by the 3, and that gave me a 3. Now, You added this column up, negative 12 and 3 gave you negative 9. Now we're going to repeat the multiplying. We're going to take this negative 9 times 3. So negative 9 times 3 is a negative 27. So right now, all we're doing is repeat the process until done. Now watch this. This number's below the line now. I multiplied by 3 to get my negative 27. Now we're going to add this up. 47, negative 27, give me a positive 20. All right, y'all, now, since the number's below the line, we're going to multiply by 3. 20 times 3 is 60. So we put that in the next column. And then we're going to add this, negative 60 and 60, give me a 0. So this is the remainder. Now remember up here, I said that when you're finding function values, the remainder is equal to the function value. Well, y'all look here. My remainder is 0. So that means f of 3 equals 0 for that function. Okay? So y'all, the last number is always the remainder. These three numbers are the coefficients of the new polynomial. So it's like we're dividing out this factor that had a 0 of 3. So once it's divided out, since this was the x to the third, this always starts 1 degree less. So this would be 1x squared minus 9x plus 20. Now later on when we're working in 8.4, these numbers will be more important, okay? But right now, all we're looking at is these remainders. So we'll worry about these numbers in 8.4. So right now, everything we're doing today depends on the remainders for function value is equal to the remainder. And then if I was looking for zeros, we look at that remainder also, okay? All right, y'all, so let's do this for f of negative 4 and f of 5 coming up next, okay? So we're going to start with f of negative 4. So I'm going to use the same coefficients. I'm going to use the same coefficients as I used here because I'm still finding the function value of putting a negative 4 into this polynomial, okay? So each one of these problems, I will always use these same coefficients. All right, y'all, so here we go. So my coefficients were 1 for the x cubed, negative 12 for the x squared, 47 for the x, and then my negative 60. We're going to leave a little space, draw our line, and box under the last number. So this time, our C, since they want me to find f of negative 4, my C will be a negative 4. All right, so these are giving me the same answer that I would get if I put that negative 4 in for the x's on that polynomial and say I punched it on my calculator or whatever, okay? All right, y'all, the same steps. Watch this. You're going to bring the first number down below the line. Now, since this number is below the line, we're going to multiply by C to get the next column. So 1 times negative 4 is a negative 4. You're going to add negative 12 and negative 4 to get the next number below the line, okay? So negative 12 and negative 4 give me a negative 16. All right, to get the next number, we're going to multiply that negative 16 times that negative 4. So that's a negative times a negative, so that's going to become a positive, and 16 times 4 gives me 64. All right, y'all, so next, we're going to add 47 and 64. That gives us 111. All right, now I need to get the last column. So I'm going to multiply 111 times negative 4. That's going to give us a negative 444. And y'all add that last column up. Negative 444 plus negative 60 gives me a negative 504. All right, y'all, so let's check and see if this is correct. Because we said this is equal to putting a, so watch this. Let's do f of negative 4 and see what we get. So that would be negative 4 cubed minus 12 times negative 4 squared plus 47 times negative 4 minus 60. So I'm going to go punch this on the calculator and see what we get. And we should get that negative 504, okay? So this is what we're wanting to show y'all, that synthetic division can be used to solve these, okay? So watch this. Negative 4. I'm going to cube that. All right, arrow right and come back down. Minus 12 times that negative 4. And that is squared. Plus 47 times negative 4. And then minus 60. All right, y'all, we would hit enter. And look at that. We get negative 504. So really, if you don't have a calculator with you and you got to evaluate a function, you can use synthetic division, which might be easier than trying to do it by hand, okay? All right, y'all, next we had f of 5. So 5 is my new c here. My coefficients are the same. 1 for the x cubed, negative 12 for the x squared, 47 for the x, and then negative 60. Hey, y'all, so look, same steps. We're going to bring the first number down. This ain't really bad. This ain't bad once you get used to doing it, okay? So watch this. 1 times 5 is 5. So that goes to the next column. We're going to add this column. Negative 12 and 5 will give you a negative 7. All right, we're going to multiply negative 7 times 5. That's a negative 35. All right, 47 and negative 35 give me a positive 12. All right, y'all. 12 times 5 is 60. And y'all look at that. Negative 60 plus 60 gives you a 0. So if you put a 5 in for these x's where I got the negative 4's at, you put a 5 into that and hit enter on the calculator, you will get an answer of 0. So this one means f of 5 equals 0, okay? So I like synthetic division. Once you get used to it, it is not bad, okay? So y'all, let y'all help me do this one here. So what we're going to do is use synthetic division. to find the function value. All right, y'all, they're giving you f of x equals x to the fourth minus x cubed minus 11x squared plus 35x minus 39. They want us to find f of a negative 5. So the first step, we're going to write all these coefficients out. And let's see, x4, x3, x2, x, and our number. Nothing's missing. So here we go. 1x4, negative 1 for the x cubed, negative 11 for the x squared, 35 for the x, and negative 39 for the number at the end. I'm going to draw my line, and I'm going to box under the last one. All righty, let's see. C for us will be negative 5. All right, y'all, so here's the thing. Here we go. First step. What's my first step? All right, y'all, so I'm going to bring down to 1. All right, next step. All right, so y'all brought down that 1. Now you're going to times the 1 by negative 5. There you go. 1 times negative 5 is negative 5. And then y'all give me this step, and then it's just going to be repetition. So what would y'all do with this? So add the numbers together. That's going to give me a negative 6. So good job, Julie. And then we're just going to keep repeating that, okay? So negative 6 times negative 5 is 30. 30 and negative 11. That's going to give me what, 19? 19 times negative 5 is a negative 95. Negative 95 and 35 is a negative 60. And y'all, let's see. Negative 60 times negative 5 is a positive 300. So we got a negative 39 plus 300. That's going to give me 261. So that means f of negative 5 equals 261. All right, y'all. So that's examples of using synthetic division to find function values. We're only looking for our remainders on those, okay? So now what we're going to use? We're going to use synthetic division to determine if numbers are zeros of a polynomial. And remember, zeros of a polynomial would be the solutions you would get by setting it equal to 0, okay? So, for this example, using synthetic division, determine if the numbers are zeros. Of the polynomial. So they'll be looking for yes or no answers on this one, okay? So this one, they got a -3, comma, 2, and then a semicolon, f of x equals 2x cubed plus 3x squared minus 3x plus 18. Alrighty, so the two numbers I'm checking, we're going to check -3 first, and then we'll check 2. These are the two numbers they want me to check to see if there's zeros or not. Here's my coefficients. Now, we're going to do this the same way we did the last problem. The only difference is this. Remember, if a number, so let's put a star by this. If a number is a zero, then the remainder must be zero. Okay? So if one of these numbers is a zero, they both could be zeros. So we're looking for an answer like yes, yes, no, no, yes, no, or no, yes. Okay? And you got to do them in order. So the first number I'm going to check is going to be the -3. So my coefficients are 2 for the x cubed, 3 for the x squared, -3 for the x, and then 18. All right, I'm going to box under my last one. So I'm looking for a zero in here to say yes. Y'all, any other number? We're saying no on this, okay? All right, y'all, here's the process, same process. Bring the first number down. So the first number always has to come below the line, okay? And then you're just going to multiply and add, multiply and add, multiply and add until you're done. 2 times -3 is -6. 3 plus -6 is -3. -3 times -3 is a +9. -3, +9 give you a 6. 6 times -3 is -18. And y'all look at that. 18 and -18 give me a 0. Since this remainder is 0, that means -3 is yes, a 0 of that polynomial. That means I know this graph crosses over the x-axis at that -3, right? All right, so let's try 2. So 2 is my next 0 I'm checking. My numbers are still the same. 2, 3, -3, and 18. I'm going to leave a little space and draw my line. All right, y'all, it's the same thing, right? Bring down to 2. 2 times 2 is 4. 3 plus 4 is 7. 7 times 2 is 14. Oh, what's that? 14 and -3 gives me 11. And y'all look here. 11 times 2 is 22. Well, if you add 18 and 22, you get 40. So since I didn't get a 0 here, that means 2 is not a 0 of that polynomial. All right, so y'all get an idea? It's not too bad. So your number four would be pretty much the same as this problem. So what I'm going to do is the last problem in this section is number five. Because it sort of has a fraction there, okay? And y'all usually don't like fractions. So I'm going to do this one as my last one for this section. So use synthetic division to determine whether a negative 3/2 is a zero of f of x. Now, f of x they're giving me equals x cubed plus 1/2 x squared plus 5/2 x minus 3/2. So, ooh, look at the fun. We got one with a lot of fractions here, okay? But y'all, I'm going to do the same processes. I'm going to come over here, and my C is the negative 3/2. My coefficients are 1 for the x cubed, 1/2 for the x squared, 5/2 for the x, and then negative 3/2 for the number at the end. So it's fractiony, so let me leave just a little more space in there. In case I get fractions, I got to put in the middle here, okay? But you'll see this, although it's fractions, I am happy they all got the same denominator on them, okay? If they had different denominators, then we would have a little more trouble on this. And plus, you got a calculator you can add your fractions on if needed. So, y'all, let's do this. Bring the first number down. Then watch this. 1 times a negative 3/2 is a negative 3/2. So when you add fractions, they got a common denominator. So that means you do the adding on top. So 1 and negative 3 is a negative 2 on top over 2. Negative 2 over 2 makes that a negative 1. Now, y'all, let me show you what you could do. You had 1/2 and a negative 3/2. All right, so your calculator, I'll just show you on this one. So you can do alpha y equals and enter. Then you can put in your 1/2 on that one. Arrow right. And then it was plus the next fraction, alpha y equals enter, was a negative 3 on top and a 2 on bottom. Since you put it in like a fraction, when I hit enter, I get negative 1 as my answer. Okay, so the calculator don't mind adding for you. So we got that negative 1. That negative 1 times that negative 3/2, a negative times a negative is going to make that a positive 3/2. All right, so you add the top. 5 and 3 is 8 over 2. 8 over 2 will reduce to a positive 4. So, y'all, you can do that one on the calculator. Alpha y equals, enter. That was 5/2. And all right, plus, and then alpha y equals enter for another fraction. And that one was 3 on top, 2 on the bottom. Once I hit enter, I get my 4, okay? All righty. 4 times a negative 3/2. So when you multiply negative 3/2 times 4, You treat the 4 like it's got a 1 on the bottom, and you multiply straight across. So negative 3 times 4 is negative 12. 2 times 1 is 2. And y'all, negative 12 over 2 gives me a negative 6. All right, so if we was doing that on our calculator, um, okay, so y'all are asking how to make a. So if you ended up with something like this, 3 divided by 2, and you got a decimal, and you want to make that into a fraction, you hit math and enter twice, and it'll change it back into a fraction for you, okay? Hey, also, what did I get here? I forgot, I think I got a 6. What did I get there? So I had 4 times negative 3 halves. That should have gave me a, so 4 times alpha y equals enter. That was a negative 3 over 2. So if you wanted to multiply on here, you can still do that. Enter, you get a negative 6. All right, so this is a negative 6 here. So now you're adding a negative 3 halves and a negative 6. So let's knock that out on the calculator. All right, y'all, so what I had a negative 3 halves, so I'll make that look like a fraction again. And then that was plus a negative 6. So let's see what that gives us. That gives us a negative 15 halves. So since I did not get a 0 for that synthetic division, that means no, negative 3 halves is not a 0 of that polynomial. So remember, when you're using it to find zeros, you got to get a 0 for that remainder for that to be a yes, okay? All right, y'all, so we will play a little bit more with synthetic division later on in 8.4. Um, but for now, that was 8.3, and it was just a couple problems finding function values, and then I think 3 problems determining if a number is a 0 or not, okay? All righty, y'all. So now 8.4. Theorems about zeros. So y'all, I hope you like foiling. Because this section, we do a lot of foiling, okay? Because what they're going to do in this section, it starts out, they're going to give you the zeros, and we're going to work in reverse and find the polynomial that came from. So instead of dividing, we're actually going to start working in reverse and doing a lot of multiplying, okay? So I'll sort of explain the steps as we do these problems. So we're going to start out with 3 real numbers first, and then they'll give me imaginary numbers, and then they'll even do radicals on us, okay? So first of all, find a polynomial of degree 3. When they say degree 3, they mean the largest exponent of your polynomial has to be a 3, okay? Now, if they're telling me it's a degree 3, that means they better give me 3 zeros. Because remember, the degree is equal to the number of zeros for that polynomial. Okay, so of degree 3 that has the given zeros, of a -3, a +4, and a -5. So they're giving me the 3 zeros of this polynomial. And they want me to work in reverse and find that polynomial. And it will have a high exponent of a 3 on it, okay? All right, so what you're going to do, since we're working in reverse, and these are the zeros, remember the zeros means it's the solutions. So what you're going to do is write it as solutions. The first solution is x equals that -3. Second solution is x equals that +4. And then the third solution was x equals -5. So my first step was to write, so right here, write the 3 solutions as equations. All right, I wrote my 3 solutions as equations. Now, get a 0 on the right side of each equation. So I'm going to get a 0 on the right side of an equation. So this one has a -3 here. If I want this to be a 0 on that side, I'm going to add 3 to both sides. Okay, what I did to this side, I got to do to that side. So this side now becomes x plus 3. And that's going to equal -3 plus 3 is 0. See how we're sort of going in reverse now? So if you got a 4 here and you want to make that side a 0, you're going to subtract 4 from both sides. And this will give you a x minus 4 equals 0. And then you're all right here. That's a -5. So we're going to add 5 to both sides. And I'm going to get an x plus 5 equals 0. So I got 3 little equations that are equal to 0. So now what I'm going to do, put each equation into parentheses and set it equal to 0. So I'm going to put each of these 3 left sides of this equation in parentheses, and I'm going to set the whole thing equal to 0. Because if this equals 0, that means the whole thing equals 0. This one equals 0. It would make the whole equation equal 0. So since these are all equal to 0, we're going to do it like this. X plus 3 times x minus 4 times x plus 5. All of that is still equal to 0. So you see how we're sort of, yesterday when we had these things factored, we took the factors, set them equal to 0, and then we solved them. So see how we're sort of going right in reverse. Now what you got to do, start multiplying. So y'all, the first 2 I'm going to multiply are going to be the last 2. So I'm going to bring down to x plus 3. I'm going to FOIL these 2 out to see what's going to go here. So on the side, I'm going to do x minus 4 times x plus 5. So see, this is starting to do a lot of foiling, okay? Once we get that answer, we'll put that here, equal to 0. And then my final step, I'll multiply this by whatever I get here. All right, y'all, so let's start here. X times x is x squared. X times 5 is 5x. Negative 4 times x is negative 4x. Negative 4 times 5 is negative 20. And when you add the like terms, you get an x squared. 5 minus 4 leaves you 1x. And then the minus 20. I'm going to put that right here. X squared plus x minus 20. All this is still equal to 0. So now guess what? These two got multiplied. Now we're going to multiply these. So I multiplied those first. Now I'm going to multiply this. So we can either do that on the side again, or we can do it right here. So y'all, I'll just do it on the side again. I'm going to do x plus 3 times x squared plus x minus 20. You distribute the x times all three of these, and then we'll distribute the 3 times all three of these, okay? So you're doing the foiling, but it's a little longer. Here, 2 things times 2 things, you had 4 parts right here. When we do this one, 2 things times 3 things, we'll have 6 parts right here, okay? All right, here you go. X times x squared is x cubed. X times x is x squared. X times negative 20 is a negative 20x. Now multiply that 3 through. 3 times x squared is 3x squared. 3 times x is 3x. 3 times negative 20 is a negative 60. All right, y'all, so let's add like terms. You got 1x cubed in the front. You got 1x squared and 3x squareds. That's going to give me 4x squareds. Right here, you got a negative 20x and a positive 3x. So negative 20 and 3 give you negative 17x. So that takes care of everything. And at the end is my negative 60. So I get an x cubed plus 4x squared minus 17x minus 60, all equal to 0. So look at that. My highest exponent was a 3, which is a degree 3 polynomial. And that's what I needed. So y'all, here's what MathLab has. They got this. F of x equals x3 plus blank x squared minus 17x minus 60. The question of the day, what goes into blank? So what would y'all put into blank? Gee, what you got, a 4? Perfect, because that's what's in front of our x squared right here, 4. So we put a 4 in there. So y'all look, on some of these, they're going to give you the whole equation, and all you're doing is putting in numbers on some of them, okay? All right, now y'all look. That was foiling 3 real numbers, okay? But let me tell you, they're going to change off of these real numbers, okay? All right, y'all, let me flip over. All right, y'all, let's try this one. I'm going to write a polynomial. This one says in standard form, whose zeros include 2, 6i, and a negative 6i. Alrighty, so let me give y'all a little refreshing on these i's here. If I multiply I times I, that equals I squared. Well, y'all, I squared equals -1. And let me show y'all that. Let's go to the calculator. Let me clear everything off. Y'all look here, by the decimal down here, there's a blue I. So if you hit the second button and the decimal, that brings the I up. And I'm just going to multiply I times itself. So I times I is I squared, but watch what that equals. That equals -1. Okay? So what that means is anytime I get an I squared, I'm going to change that to a -1. Okay? That's important when you're foiling these imaginaries here. So recall that every time, okay? All right, so I got 3 zeros, which means when I'm done, my biggest exponent will be what? All right, y'all, so remember this. If you got 3 zeros, when you're done, your highest exponent will be a 3 on this, okay? So the number of zeros is equal to the degree. All right, y'all, so let's write them out. I got x equals a +2, x equals 6i, x equals a -6i. All right, so we started out with our solutions. Now we're going to get a 0 on the right side by moving these numbers over. So the first one, you're going to subtract 2 from each side, and that's going to give you x minus 2 equals 0. This one, I'll subtract 6i from both sides. X minus 6i equals 0. And then here you're going to add 6i. And I get x plus 6i equals 0. So I'm doing them the same as I did the real numbers, but I'm going to be a little more picky on this one, okay? So I got my 3 equations. I'm going to put everything, all these factors are going to go into parentheses. Everything now equal to 0. Now, here's the thing on this one. You definitely want to start fooling with these imaginary numbers first, okay? So let's do that on the side here. I'm going to do x minus 6i times x plus 6i. And y'all, I'll tell you a little trick on these. We call these conjugate pairs. They look exactly the same except one's being subtracted, one's being added. When you multiply conjugate pairs, the two middle terms always cancel each other out. So watch what I'm going to do. I got an x times an x, that's an x squared. X times 6i is a positive 6ix. Now I'm doing a negative 6i times that x is a negative 6i times x. Now y'all watch this one. That negative 6i times a positive 6i is a negative 36i squared. So look here in the middle. 6ix, negative 6ix. Those cancel. So I got my x squared. And y'all, there's an I squared. What did we say I squared equaled? Well, look right there. Good job, Jason. We said it equaled -1. So what's that -1 going to do to that negative 36? It's going to make it positive. Good job. So this negative 36i squared became a positive 36. So y'all look here. The middle's canceled. So when we're done, we only got two terms. And y'all check this out. Anytime you multiply conjugate pairs of imaginary numbers, it ends up positive, okay? All right, so that brings down this x minus 2. This gave me a x squared plus 36. All this technically now is equal to 0. But y'all look what happens. When you FOIL the imaginary pairs of the conjugate pairs of imaginary numbers, the i's are gone. You have no more I. The imaginary stuff is history because it canceled out here and then this turned into a -1. All right, y'all, so all that's left here is to multiply that. So we multiplied this. Now we're going to multiply this. All right, so on my side, I'll do that one again. I got x minus 2 times x squared plus 36. All right, y'all, whenever I get here, I'll put here and be done, okay? So x times x squared gave me an x cubed. X times 36 gave me a 36x. Then I got a -2 times x squared is a -2x squared. And y'all finally, -2 times 36 is a -72. Now look, I don't have any like terms, but what I'm going to do is put them in order. My x3 first, then my -2x squared, then my plus 36x, and then minus my 72. So I just move these two around to put it in order so that I end up with an x cubed minus 2x squared plus 36x minus 72. All right, y'all. And then on this one, on MathLab, you had to put these numbers in. The 2, then they wanted the 36, and then the 72. MathLab had the minus here. You just had to put a 2. It had the plus here. You put the 36. And then it had that minus. You put the 72. So most of these, it's giving you blanks and you're going to just put your answers in, okay? All right, y'all, how about this? I'm going to pause us for a second so we can take a break. Resume. Hey, y'all, so look at this next one. I'm going to find the polynomial of lowest degree. um, having the zeros of, oh, where'd it go? Square root of 6, a negative square root of 6, and 5. All right, so they're giving me radicals on this one. So on this, we got to recall one thing. A radical times itself equals the number under the radical. So watch this. A times A is A squared, and the square root of A squared is A. So if this was a square root of 2 times square root of 2, it would equal 2. Square root of 5 times square root of 5 equals 5. In my case, square root of 6 times the square root of 6 equals 6. So if you square a radical times itself, it equals the number under the radical, okay? All right, so that's going to help us in this section. Now, always put the radicals and imaginary stuff last. So when I write out these solutions, I'm going to put my x equals 5 first. Then I'll do my x equals a square root of 6. And then I'll do x equals a negative square root of 6. All right, y'all, same thing. We need a 0, so we're going to subtract 5, subtract square root of 6, add square root of 6. Okay, so let's knock that out. X minus 5 equals 0. This one I'm subtracting the square root of 6. So x minus the square root of 6 equals 0. And then here I'm going to add that square root of 6. And we'll get x plus a square root of 6 equals 0. And I'm still doing them in the same way. I got my 3 equations. I'm going to put them all in parentheses now. X minus 5, x minus square root of 6, x plus square root of 6, all equal to 0. So once again, notice these are conjugate pairs, like the i's I had a while ago. One I was negative, one I was positive. So I'm going to start out multiplying these. Okay, so I'll bring down that x minus 5. And then whatever I get from multiplying these will come right here, okay? So let's do that on the side. X minus square root of 6 times x plus square root of 6. Now remember, these are conjugate pairs, so once again, the middle terms are going to cancel. And when you multiply conjugate pairs of radicals, the radicals will disappear. Just like a while ago, the I disappeared, the imaginary stuff. Well, these conjugate pairs, the radicals will disappear, okay? So y'all watch this. X times x is x squared. X times square root of 6 is a positive square root of 6x. So look here. When you multiply a variable times a radical, the radical, when you're doing radicals, you can only multiply inside the radical times inside the radical, okay? So since this x is not under a radical, you can't put it under the radical. You got to keep it outside. All right, y'all, here's a negative square root of 6 times x. I get a negative square root of 6 times x. And then look here, negative square root of 6 times a positive square root of 6 is a negative square root. Since the 6 is under and the 6 is under, I can multiply them and get a 36. So let's see. Plus square root of 6 minus square root of 6. Those x's canceled. So I'm going to bring down that x squared. And then here, You got minus. What's square root of 36? Is 6. So once again, a square root of 6 times the square root of 6 in the long run equaled 6. And that's what this told me right here. Okay? So at this point, you could have put a 6 here if you didn't want to put the square root of 36. I just do the extra step so that you can see really where that's coming from, okay? So that square root of 36 is what happened and turned into that. So y'all, x squared minus 6 will go over here. All equal to 0. Alrighty, so remember, I had 3 zeros, so when I'm done, I better get an x cubed on this, okay? So y'all, right here, you're going to multiply. So on the side, x minus 5 times x squared minus 6. All right, y'all, here we go. X times x squared is an x cubed. X times negative 6 is a negative 6x. Negative 5 times x squared is a negative 5x squared. And then that negative 5 times negative 6 is a positive 30. And notice the only thing I can do is rearrange it because I don't have any like terms, but I need to put the negative 5x squared second. So I get the x cubed minus the 5x squared minus 6x plus 30. And y'all, that would be our x cubed minus 5x squared minus 6x plus 30 equals 0. So on this one, MathLab actually had A, B, C, D with 4 different answers. And we would have picked the one that had the x cubed minus 5x squared minus 6x plus 30. Okay? Alrighty, so first 3 problems in your homework are definitely going to be a lot of foiling. So let's look at some other properties about zeros. You know, this is 2 little properties we're going to look at. And it deals with the imaginary zeros and the radical zeros. So here's the thing. Imaginary zeros. Always. And you can underline that always. But imaginary zeros always come in conjugate pairs. Okay? They always come in conjugate pairs. So what that means is this. If 2y is a 0, then negative 2y is also a 0. So 2y and negative 2y are conjugates of each other. If 3 plus 4i is a 0, then 3 minus 4i is also a 0. Conjugate pairs, 3 plus 4i and 3 minus 4i. Those are conjugate pairs. So if one of these is a 0, automatically the other one would be a 0 too, okay? All right. That's on imaginary. That's why when I did the one while ago with the I had what a 6i. So that's why negative 6i was also a 0 because they're always in conjugate pairs because these imaginary ones, remember, come from those square roots you try to take of negative numbers. And remember, square roots always had a plus or minus in front of them, okay? So that deals with imaginary zeros. What about radical zeros? Well, guess what, y'all? Radical zeros always come in conjugate pair. Hey, that's why this one we had the square root of 6 and the negative square root of 6. They come in conjugate pairs. So if square root of 5 is a 0, then negative square root of 5 is also a 0. If 3 minus square root of 2 is a 0, then 3 plus square root of 2 is also a 0. Notice the number in front don't change. It's what's in front of these radicals that changes. 3 minus square root of 2, 3 plus square root of 2. Square root of 5, negative square root of 5. If one of these is a 0, then the other one has to be a 0 also, okay? So remember that for these next few questions. Yeah, y'all, here we go. Let's see what y'all think on these ones, okay? So I'm going to let y'all answer some of these. So y'all check this out. Suppose a polynomial of degree 4 has the given numbers as zeros. They want me to find the other 0. So they're giving me a negative 3. They're giving me a square root of 3. And they're giving me a 14 fifths. So remember, since it's a degree 4, it's going to have 4 zeros. So here's the question. What is my other 0? If negative 3 is a 0, square root of 3 is a 0, and this fraction 14 fifths is a 0, any guesses? What is my fourth 0? Justin, where are you getting that 4 at? So here's what I want y'all to remember. The degree just tells me how many zeros I'm having. So let me ask y'all this. Out of these three numbers, which one of these would have a conjugate pair? Oh, the square root of 3. Perfect. And it's going to be a negative square root of 3. Good job. So negative square root of 3 would be my utter 0, remember, because these square root of 3's always come in conjugate pairs. All right, good job. All right, try this one. Suppose a degree 4 polynomial has some of its zeros of I and 4 minus square root of 11. Find the other zeros. All right, so the other zeros are blank. Well, y'all, both of these have conjugate pairs. If this is I, if I is a 0, then it's going to be the negative I. Good job. And then square root of 11. Um, so, and actually on this one, you got to write the whole thing. So instead of 4 minus square root of 11, this one would be 4 plus square root of 11, okay? So it's got to look like it other than the minus turns into a plus, okay? And this plus turns into a minus on that one. Well, y'all, then number 9 does the same thing. Not number 9, that's like number what, 6 or so? It does the same thing. Um, it gives you 2, and you're going to find its opposites on it. So here, what is this all leading to? This is leading into doing what I'm about to do for you. We're going to find a polynomial of lowest degree um, that has zeros of negative 2i and 7. All right, so look what they're wanting. So let me put a line through that because this is sort of changing. Now we're going back to finding polynomials again. Okay, so they want you to find a polynomial of lowest degree. So they're not telling you the degree because there's things they want you to realize on this one. Okay? First off, this polynomial has degree of zeros of negative 2y and 7. Does it have any more zeros? It's going to be positive 2i. There you go. So that means 2i must also be a 0. Because if they give you one imaginary, you automatically got to get the other one, okay? So so since we're finding a polynomial, I'm going to do x equals 7, and then x equals negative 2y, and x equals positive 2y. So it's doing what we did on the first 3 problems, but now when they give you an imaginary, they want you to realize that the conjugate must also be a 0 also, okay? In the first problem, they gave me the 6i negative 6i. Now they're just giving me one of them, okay? But we're doing the same thing we did on that second problem. I'm going to get zeros on the right side by subtracting 7 on this one, adding 2i to this one, and then subtracting 2i from my last one. And then remember, put them all in parentheses equal to a big 0. And y'all, I'm going to start out by multiplying my imaginary. So on the side, I'm going to FOIL the x plus 2y times the x minus 2y. Now remember, when we're done with this, it will not have any imaginary stuff left because these are conjugate pairs and it cancels all the I stuff out, okay? All right, y'all, here we go. X times x is x squared x times negative 2y is a negative 2ix. Positive 2y times x is a positive 2ix. And y'all, 2y times negative 2y is a negative 4i squared. All right, so you notice those cancel again. So I'll bring down the x squared. What is this going to equal? Negative 4i squared. Now remember, I squared equaled what? What does I squared equal, we said? Okay, negative 1. So that negative 4 times that negative 1 is going to make that a positive 4 for us, okay? So don't take square roots of that. Just change that I squared into a negative 1, multiply them together. So if you think about it, all the I squared does in life is it turns that negative number into a positive. All right, so over here, we got x minus 7 times x squared plus 4. So now we're going to multiply this. Okay? So I'm going to do that on the side here. I'm going to do my x minus 7 times x squared plus 4. Once we FOIL this, we will be done, okay? So x times x is x cubed. X times 4 is 4x. Then you got negative 7 times x squared is a negative 7x squared. Negative 7 times 4, negative 28. And y'all, I'm just going to put them in order again. So I get an x cubed minus 7x squared plus 4x minus 28. And guess what? That is our final answer. X cubed minus 7x squared plus 4x minus 28 all equal to 0. So let's see, on that one, MathLab will have the f of x part for us. All we do is put in the polynomial. Okay, so it'll have f of x, and you're just putting in the polynomial, okay? Alrighty, so that's why you had to know about this conjugate pair stuff, so that you could actually come up with the polynomials. So y'all, I'll give y'all a second to catch up, and then we'll do another one of these. All right. Now y'all, same thing. Find a polynomial of lowest degree um, with sum of the zeros of square root of 3 and 5i. So once again, they're not telling you what degree you're going to end up with. They're just giving you a couple zeros. So if they gave me these zeros here, then what else must be a zero? Well, that means a negative square root of 3 and a negative 5i must also be zeros. So if they give you radical, automatically it's opposite or it's conjugate. If they give you an imaginary, automatically it's conjugate. So this means this polynomial is going to have 4 zeros, which will make it a degree 4 when we're done. My highest exponent will be a 4, okay? Now I'm going to put them together. X equals square root of 3. X equals a negative square root of 3. X equals 5i. X equals negative 5i. So I keep these two together because they're going to be conjugates, and then these two will be conjugates. So it goes a little quicker when you got conjugates happening, okay? So first thing, let's get them zeros. So I'm just adding their opposites to each side. I got all these equations. I'm going to set them all inside the parentheses now. Now think on this one, since I've got conjugates, I'm going to multiply the first two, and then I'm going to multiply the last two. That way I can just keep them in order here, okay? Instead of doing them all on my side. So first I'll do these two and put them in parentheses, and then I'll do these two and follow along in their parentheses, okay? Now, y'all, let me show you a shortcut on these. Since these are conjugate pairs, um, shortcut for foiling conjugate pairs. So if I got A plus B times A minus B, this is what I'm going to do to both of these pairs over here. I'm going to do the shortcut because y'all, those middle two terms always cancel. So what we can do is multiply A times A and get an A squared. And then B times negative B gives me a negative B squared. So we can multiply the first two terms and the last two terms if they're conjugate pairs like these both are. Because this BA in the middle cancels with that negative BA every time. So y'all, let's shortcut these. X times X is X squared. Square root of 3, a negative square root of 3 times a positive square root of 3 is a negative square root of 9. Now, I could have put a 3 here, remember, because the square root of 9 is a 3, and a radical times itself equals a 3, but I'm just putting that extra step on this. Now, let's do that over here. X times X is X squared. Negative 5i times 5i is a negative 25i squared. All right, so let's finish this. Square root of 9 is 3. So this one gives me an x squared minus 3. This one's going to give me x squared. Uh-oh, y'all, look at that. What's that? I squared equals negative 1 still. So that negative 1 is going to turn that negative 25 into a positive 25. Y'all remember this. When you FOIL conjugate pairs of radicals, they end up negative. When you FOIL conjugate pairs of imaginary numbers, they always end up positive. And that's every time, okay? All right, so nothing else I can do to those. So now I'm going to multiply these times each other and get my final answer. So y'all, here we go. X squared times x squared is a x to the fourth. X squared times 25 is 25x squared. Negative 3 times x squared is a negative 3x squared. And y'all, finally, negative 3 times 25 is a negative 75. So my question is, can you go further for this problem? And y'all, I wanted y'all to notice. Yeah, Jason, right, because you got x's in the middle, x squareds. Uh-huh. So it's going to be x4. 25 minus 3 leaves me 22x squareds. And then my minus 75. And then once again, math lab will have the f of x equals, and in the blank, you would put that. x4, 22x squared, minus your 75. All righty, y'all, I'm going to do something real quick. Y'all need to chat me whether y'all are in this class or not, because I don't get but one person responding most of the time. And y'all just put on your chat if you're here. Say here for me, okay? All right, Mackenzie's here. Good job. Julie's here. Okay. All right, y'all, just making sure because I'm not seeing but one or two. Okay, so that'll work. So four of y'all are here actually. All righty, y'all. So y'all listen here. So now these last few problems, we're getting back into finding zeros. And this is where that synthetic division is coming in, okay? So let me show you what we're doing here. The polynomial function has the given zero. They want me to find the other zeros. So this is where I'll explain about that quotient type stuff on these synthetic divisions, okay? So let's see what they're giving me. They're giving me f of x equals x to the third plus 6x squared minus 2x minus 12. And then they got a semicolon and -6. So that means -6 is the zero they're giving me of this polynomial. And they want me to find the other zeros. So here's what we do. We're going to do synthetic division. And we're sort of going to divide this one out, okay? So let's put our first. The zero we know they gave me was -6. I'm going to write my coefficients. 1, 6, -2, and -12. Remember, leave you a little space. So what we do, y'all, when they give you a polynomial with a zero and you're finding the other zeros, you sort of divide this zero out And what's going to happen, you're going to have three numbers under here. You started with four numbers. This will give me three numbers of the new quotient that we got when we divided this out. So this will be like your x squared, your x, and a number term. When you got three numbers under here, we use the quadratic stuff, the quadratic formula, the square roots, ever how we solve the quadratic part. But that's what we're going to do with them three numbers. It'll be like an A, B, and C. But you got to do synthetic division until you get it from four numbers down to three, okay? All righty. Now let me ask you all this. If this -6, they said it was a zero of this polynomial, since -6 is a zero of this polynomial, what's the remainder got to be when we're done? All right, it's got to be zero. Y'all good. Perfect. Perfect. Now, if we don't get a zero here, we did something wrong on this, okay? All right, y'all, here we go. So bring that one down. 1 times -6 is -6. All right, 6 and -6 are going to give you a 0. 0 times -6 is 0. All right, y'all. -2 plus 0 is -2. And y'all look at that. -2 times -6 is a positive 12, which gives me a 0 remainder. So we knew that because they told us that that was actually a 0 of it, okay? So y'all, these three numbers are the coefficient of the new polynomial, and it always starts 1 degree less than the original. So since this was an x3, that makes this one a 1x squared. So this is like an x squared plus 0x minus 2. Now, if you wanted to do the quadratic formula, A is 1, B is 0, C would be -2. But y'all look at this. X squared plus 0x minus 2, that's actually x squared minus 2. I'm going to set that equal to 0 and solve it without doing the quadratic formula. So since that's a 0x, it sort of goes away, okay? And you're left with an x squared minus 2. Easiest way to solve this, add 2 and do the square roots to it. So we're going to solve the quadratic equation to get the last two zeros. So I use some kind of quadratic once I'm down to three numbers to always get my last two zeros, okay? So here I'm going to add 2. So I get my x squared, that cancels. That equals 2. Now we do square roots to both sides. So square root of x squared is x. Now y'all remember, since we're doing a square root of a number, we got to do a plus or negative. And y'all guess what? I can't do nothing with that square root of 2. So that's going to stay square root of 2. So for this one, it'll say the other zeros are blank. We would put in a square root of 2 and a negative square root of 2. You do not put in the -6 because that one they gave you, okay? Oh, y'all, so that's why we learned synthetic division. Okay, so Mackenzie, it's like this. Remember, this was the x cubes, the x squareds, the x's, and the numbers here. Those were these coefficients. So what happens after you divide out one of the factors like that -6, these three numbers are the coefficients of the new polynomial. This is what you call the quotient. So they're always in descending order. So the last number is always the number at the end. And then this would be the x term, and this would be the x squared term. So if you started with an x cubed, That means this is now an x squared term, x and a number. So it always starts out 1 degree less. Now, Mackenzie, watch this next one I'm about to do because we're going to start out with an x4 on it, okay? So let me show y'all what's happening on it. So the same thing for the polynomial, 1 0 is given. And guess what? Whoops. They want me to find the other zeros. Okay, so let me see what they're giving me to start out with. This one, they're giving me P of X equals X to the fourth plus 55 X squared minus 576. Then they got a semicolon and they're telling me 8i is a 0. All right, so check this out. That's an X4. Since that's a 4, I am looking for 4 zeros. They're giving me one of them. So I got to find the other 3. Now, the first thing you notice, I don't have an X cubed term and I don't have an X term here. It goes from X4 to X2 to my number. So for the missing terms, I'm going to add a 0. So y'all watch what I got. I got 1x4. I got 0x cubes. Then I got 55 for my x squareds. I got 0 x's. And then at the end, my number is a negative 576. So since I didn't have an x cubed and an x, we have to put zeros as placeholders, okay? All right, so let me mark that off. Now, they gave me the 0 of 8i. So check this out. When we're done, we're going to have 4 numbers under here. So since I started with an x4, that means this would be an x3, x squared, x, and my number. They're always going to be 1 degree less than the polynomial started, okay? So y'all, let's work this and then I'll sort of show y'all that. So 8i is my 0 I'm checking. So the first thing I'm going to do, bring that 1 straight down. All right, y'all, let's see what we get. 1 times 8i is 8i. And y'all remember, when I'm done, I better get a 0 here, okay? All right, let's try this. 0 plus 8i is 8i. Now, y'all watch this. I got an 8i times an 8i. So let's do that right here. 8i times 8i is a 64i squared. What will I turn that 64i squared into? All right, good job, Jason. That's a negative 64. All right, y'all. Negative 64 and 55. That's going to give me what? A negative 9. All right, y'all, here we go. Negative 9 times 8i is a negative 72i. 0 plus negative 72i is a negative 72i. All right, so now we got negative 72i times 8i. So, so y'all, let's multiply that. Now remember, we got a calculator if you want to use it. All right, so that's a negative 576I squared. And what's that I squared doing to that negative 576? It's going to make that a positive 576. Good job, y'all. And look at that. Negative 576, 576, give me a remainder of 0. Well, we knew that because they told me 8i was a 0. So, y'all, what's this mean? You got four numbers here. So remember, if this one was an x4 when you started, this now means this is 1x cubed plus 8i x squared minus 9x minus 72i. This is now the new polynomial that we got when we took out that 8i. So this will be the four numbers I use now. I got a 1 for the x cubed, 8i for the x squared, negative 9 for the x, and a negative 72i. Oh no, y'all check this out. I still got four numbers. I don't know what number to try next. They only gave me one. They gave me an 8i. So do y'all have any idea what my next number would be that I would check? Oh my God, perfect, Julie. It's a negative 8i. Because remember, if 8i is a 0, then negative 8i automatically has to be a 0, okay? Good job. All right, y'all, same process. Bring the 1 down. Now, after I do this, this will give me three numbers. In those three numbers, I'm going to solve doing some kind of quadratic method, okay? Y'all watch this. 1 times negative 8i is a negative 8i. 8i and negative 8i, give me a 0. 0 times negative 8i is 0. Negative 9 plus 0 is negative 9. And y'all look at that. Negative 9 times negative 8i is a positive 72i. When you add them, you get a big 0. So this is like 1x squared now plus 0x minus 9. So y'all, I'm going to get rid of the 0x and make this an x squared minus 9. I'm going to set this equal to 0 to get my last two zeros, okay? And y'all, what are we going to do? We're going to solve this by square roots. So I'm going to add 9. I get x squared equals a positive 9. And then let's do square roots to both sides. All right, so that's going to give you x equals a plus or minus. And y'all square root of 9 would give me what? A plus or minus 3. Perfect, Julie. So on this one, your other zeros are blank. We got the negative 8i, and then a 3 and a negative 3. Remember, do not put the 8i because they gave you that one, okay? They just want the other 3. All right, y'all. So that's why we hit y'all with that conjugate pair stuff. The i's always come in pairs and the radicals, okay? All right, y'all. So the very last problem, we're going to do a little bit different on it, okay? All right. So for the last one, this one has an A and a B. So for A, they want me to find the rational zeros and then the other zeros of the polynomial, and they're giving me f of x equals x cubed minus 91x plus 90. Then for b, they want me to factor into linear factors. And what that means is just put them in parentheses, okay? So I'll show you what they're talking about on that in a second. So first, let's do part A. So f of x is x cubed minus 91x plus 90. So if I'm going to be able to solve this one, I'm going to have to graph it and at least get one of my zeros, okay? Now on this one, when you graph it, watch what happens. So I'm going to share my calculator. I'm going to clear all that off and go to y equals. And y'all, I'm going to put my polynomial in here. I had x to the third, arrow right, and then I had minus 91x, and then plus 90. What I'm looking for is at least one x-intercept where it crosses over the x-axis. So I'm going to graph it and see what this looks like. All right, so you can see 2 points where it's crossing over. It looks like it's definitely crossing at that 1. And then let's see, 2, 3, 4, 5, 6, 7, 8. Looks like it's crossing over at 9 right there. And then this left side, I'm going to zoom left because it looks like it got another line over here on the left side. Oh, that ain't letting me go nowhere. So, all right, let me go to my table. So, it crossed over at positive 1. And see how that y value is 0? So I know positive 1. And that other one was negative 10. So let me go to negative 10, Jesselyn, and see. Yeah, negative 10, I got a 0. So that means negative 10 is a 0. So we're looking for y values of 0. Um, Positive 1 would be a 0. And then y'all, let's find our last one. That looked like that was over at, what did we say, 9? And if you go to 9, you get a 0. So that means I've got my 3 zeros because that was the x to the cube, right? So we know our zeros now. So that one, actually, we could see the 3 zeros. Now, what would happen if I could only tell one of these numbers? Then I would do synthetic division and divide one of them out and then do the last two by the quadratics. But on this one, usually your 3 numbers are going to be where that graph is crossing your x-axis, okay? All right, so then, and these are all rational zeros. So rational zeros are negative 10, comma, 1, comma, 9. And they're only rational zeros for this one, okay? Now, what would happen if you only seen the graph cross it in one place? Then you would divide that number out and then do the quadratic stuff on the other ones. If you ended up with a radical, like a square root, or an imaginary, those would be what we call other zeros. But rational zeros are these kind of numbers. And remember, rational numbers are numbers that look like fractions. So these all could be a fraction if you put a 1 under them, technically. That's why they're called rational. All righty, y'all. So that was A. And we did this, we found by graphing the polynomial. So that would have been our A. So B says factor into linear factors. So that'll be what you do. Each of these are the zeros. Well, remember, zeros always have the opposite sign than the factors. So if negative 10 is a zero, then that means x plus 10 is a factor. If 1 is a zero, then that means x minus 1 is a factor. And then if 9 is a zero, that means x minus 9 is a factor. So this is what they wanted on part B, is for you to just change the zeros into the factors, okay? All right, y'all. So 8.4 is a little long because of all the foiling in the first part of it. And then it's not too bad, but then you had to do a lot of conjugate pair stuff. Just remember that imaginary and radicals always come in conjugate pairs, okay? All right, y'all. So let me ask y'all, do y'all have any questions? Do y'all none now? All right, so play with this tonight because this section is tricky. And if I need to fix y'all, I can fix y'all tomorrow after class, okay?